The National Electrical Code, or NEC, does not specifically mandate the use of pigtails for neutral connections within receptacle boxes. However, the practice of using pigtails is widely recommended for both hot and neutral connections to enhance safety and maintain circuit integrity, particularly when a receptacle is removed. Section 300.13. One of the NEC addresses the protection of conductors entering boxes, enclosures, fittings, or raceways. It stipulates that conductors must be shielded from abrasion and physical damage by utilizing smoothly rounded insulating bushings or by sealing them with an approved insulating compound. This requirement extends to all conductors entering a box, including the neutral conductor, emphasizing the need for protection against potential damage. Pigtails, which are short wire segments used to connect neutral wires within a box, offer one method of achieving this protection. While the NEC does not explicitly require pigtails, their use presents several distinct advantages. Firstly, safety is significantly enhanced. Pigtails prevent the circuit from being disrupted if a receptacle is removed. Secondly, reliability is improved as they ensure a secure electrical connection, which reduces the likelihood of loose connections that can lead to arcing and electrical fires. Thirdly, maintenance is simplified as pigtails make troubleshooting and repairing electrical issues easier. Although not mandated by code, the use of pigtails is a common practice in both commercial and residential electrical installations, especially in new construction projects. Many electricians consider pigtails a best practice because of their positive impact on safety and reliability. In conclusion, despite the absence of a specific NEC requirement, the use of pigtails for both hot and neutral connections in receptacle boxes is strongly recommended. This practice offers a multitude of benefits, substantially improving the safety, reliability, and ease of maintenance of electrical systems. Understanding the nuances of this practice requires a deeper look into various aspects of electrical wiring and safety. Firstly, consider the basic function of a receptacle. It is a point of connection for electrical devices, and its proper functioning is critical for the safe operation of these devices. When a receptacle fails or needs replacement, disconnecting it from the circuit is necessary. Without pigtails, the entire circuit's continuity depends on the receptacle's connections. Removing the receptacle breaks the circuit, potentially disrupting power to other devices downstream. Pigtails, on the other hand, create a separate, independent connection point for each wire, ensuring that the circuit remains intact even when the receptacle is removed. Secondly, examine the specific wording of NEC section 300.13. B1. While it doesn't explicitly mention pigtails, it emphasizes the protection of conductors. This protection can be achieved in various ways, but pigtails offer a particularly effective solution. By using pigtails, the actual circuit conductors remain undisturbed within the box, shielded from the stress and potential damage associated with repeated connections and disconnections. Thirdly, appreciate the role of secure connections in preventing electrical fires. Loose connections are a leading cause of electrical fires because they create resistance, which generates heat. Over time, this heat can degrade the insulation of the wires, leading to short circuits and fires. Pigtails, when properly installed, create a solid, reliable connection that minimizes the risk of loose connections and subsequent heat buildup. Fourthly, understand the maintenance benefits of using pigtails. When troubleshooting electrical problems, it is often necessary to disconnect and reconnect wires. Pigtails make this process easier and safer by providing a clear and organized connection point. They also reduce the risk of damaging the main circuit conductors during troubleshooting. Fifthly, consider the perspective of experienced electricians. Many electricians who have worked in the field for years have seen firsthand the benefits of using pigtails. They understand that, while not required, pigtails represent a proactive approach to electrical safety and reliability. They often incorporate pigtails into their work as a matter of best practice, regardless of whether it is explicitly required by code. Sixthly, reflect on the broader implications of electrical safety in residential and commercial settings. Electrical systems are a critical part of modern infrastructure, and their safe operation is essential for protecting people and property. By using pigtails, electricians can contribute to a safer electrical environment, reducing the risk of accidents and fires. Seventhly, delve into the practical aspects of installing pigtails. The process involves stripping the insulation from the ends of the wires, twisting them together with a short length of wire, and securing the connection with a wire connector. It is important to use the correct size wire connector for the number and gauge of wires being connected. Also, the connection must be tight and secure to ensure good electrical contact. Eighthly, address some common misconceptions about pigtails. Some people believe that pigtails are unnecessary or that they add extra cost and complexity to the wiring process. However, the cost of pigtails is relatively low, and the added complexity is minimal. The benefits in terms of safety and reliability far outweigh any perceived drawbacks. Ninthly, consider the long-term cost savings associated with using pigtails. While the initial cost of materials may be slightly higher, the reduced risk of electrical problems and ease of maintenance can lead to significant cost savings over the life of the electrical system. Tenthly, explore the alternative methods of connecting wires in receptacle boxes. While pigtails are a preferred method, other options include using push-in connectors or wrapping the wires around the receptacle screws. However, these methods may not be as reliable as pigtails, especially in high vibration or high stress environments. 11thly, acknowledge the role of ongoing education and training in promoting best practices in electrical wiring. Electricians should stay up to date on the latest codes and standards, as well as the best practices for installing and maintaining electrical systems. 12thly, understand the importance of using quality materials when installing pigtails. The wire, connectors, and tools used should be of high quality and appropriate for the application. This will help ensure a safe and reliable connection. 13thly, recognize the responsibility that electricians have to protect their customers and the public from electrical hazards. By using pigtails and following other best practices, electricians can demonstrate their commitment to safety and professionalism. 14thly, discuss the specific situations where pigtails are particularly important. These include installations in high vibration environments, locations where receptacles are frequently removed and replaced, and circuits that serve critical loads. 15thly, analyze the potential consequences of not using pigtails. These consequences can range from minor inconveniences, such as a loss of power, to serious hazards, such as electrical fires. 16thly, emphasize the importance of proper grounding in electrical systems. Pigtails can also be used to connect grounding wires, ensuring a continuous and reliable ground path. 17thly, explain the different types of wire connectors that can be used with pigtails. These include twist-on connectors, push-in connectors, and crimp connectors. Each type has its own advantages and disadvantages, and the choice of connector will depend on the specific application. 18thly, provide guidance on how to inspect pigtail connections to ensure that they are properly installed and maintained. This includes checking for loose connections, corrosion, and damage to the insulation. 19thly, address the issue of wire fill in electrical boxes. When adding pigtails, it is important to ensure that the box is not overfilled with wires. Overfilled boxes can create a fire hazard and make it difficult to work on the electrical system. 20thly, discuss the use of pigtails in other electrical applications, such as lighting fixtures and junction boxes. 21st, explain the concept of voltage drop and how it can be affected by the length and gauge of the wires used for pigtails. 22nd, emphasize the importance of following the manufacturer's instructions when installing wire connectors and other electrical components. 23rd, discuss the use of torque screwdrivers to ensure that connections are properly tightened. 24th, explain the different types of wire strippers and their proper use. 25th, emphasize the importance of the energizing circuits before working on them. 26th, discuss the use of lockout-tagout procedures to prevent accidental re-energization of circuits. 27th, explain the different types of electrical testers and their proper use. 28th, emphasize the importance of wearing appropriate personal protective equipment when working on electrical systems. 29th, discuss the use of arc fault circuit interrupters, or FSIs, to protect against electrical fires. 30th, explain the different types of ground fault circuit interrupters, or GFCIs, and their proper use. 31st, emphasize the importance of regular electrical inspections to identify and correct potential hazards. 32nd, discuss the benefits of hiring a qualified electrician to perform electrical work. 33rd, explain the process of obtaining an electrical permit for new construction or renovation project. 34th, emphasize the importance of complying with all applicable electrical codes and regulations. 35th, discuss the role of electrical safety organizations in promoting safe electrical practices. 36th, explain the different types of electrical hazards and how to avoid them. 37th, emphasize the importance of educating the public about electrical safety. 38th, discuss the role of technology in improving electrical safety. 39th, explain the concept of smart homes and their impact on electrical systems. 40th, emphasize the importance of planning and designing electrical systems carefully. 41st, discuss the use of computer-aided design, or CAD, software for electrical design. 42nd, explain the different types of electrical drawings and their proper use. 43rd, emphasize the importance of labeling electrical circuits clearly. 44th, discuss the use of cable trays and raceways to organize and protect electrical wiring. 45th, explain the different types of conduits and their proper use. 46th, emphasize the importance of fire-stopping electrical penetrations through fire-rated walls and floors. 47th, discuss the use of surge protectors to protect electronic equipment from power surges. 48th, explain the different types of lighting systems and their energy efficiency. 49th, emphasize the importance of energy conservation in electrical systems. 50th, discuss the use of renewable energy sources, such as solar and wind power, in electrical systems. 51st, explain the concept of net metering and its impact on renewable energy systems. 52nd, emphasize the importance of battery backup systems for critical loads. 53rd, discuss the use of generators for emergency power. 54th, explain the different types of transfer switches and their proper use. 55th, emphasize the importance of regular maintenance of generators and battery backup systems. 56th, discuss the use of uninterruptible power supplies, or UPSs, to protect sensitive electronic equipment from power outages. 57th, explain the different types of motor control systems and their energy efficiency. 58th, emphasize the importance of proper motor selection and sizing. 59th, discuss the use of variable frequency drives, or VFDs, to control motor speed and energy consumption. 60th, explain the different types of power distribution systems and their advantages and disadvantages. 61st, emphasize the importance of grounding and bonding in power distribution systems. 62nd, discuss the use of transformers to step up or step down voltage levels. 63rd, explain the different types of overcurrent protection devices, such as fuses and circuit breakers. 64th, emphasize the importance of coordination of overcurrent protection devices. 65th, discuss the use of power quality monitoring equipment to identify and correct power quality problems. 66th, explain the different types of power quality disturbances, such as voltage sags, swells, and harmonics. 67th, emphasize the importance of power factor correction in electrical systems. 68th, discuss the use of active harmonic filters to reduce harmonic distortion in electrical systems. 69th, explain the different types of metering systems and their accuracy. 70th, emphasize the importance of accurate metering for billing and energy management. 71st, discuss the use of smart meters to provide real-time energy consumption data. 72nd, explain the concept of demand response and its impact on electrical systems. 73rd, emphasize the importance of cybersecurity in electrical systems. 74th, discuss the use of fire-resistant cables and wiring methods. 75th, explain the different types of fire alarm systems and their components. 76th, emphasize the importance of regular testing and maintenance of fire alarm systems. 77th, discuss the use of emergency lighting systems to provide illumination during power outages. 78. Explain the different types of exit signs and their proper placement. 79. Emphasize the importance of accessibility in electrical design. 80th. Discuss the use of accessible outlets and switches. 81st. Explain the different types of communication systems and their integration with electrical systems. 82nd. Emphasize the importance of data cabling standards. 83rd. Discuss the use of fiber optic cabling for high-speed data transmission. 84th. Explain the different types of audio-visual systems and their integration with electrical systems. 85th. Emphasize the importance of proper grounding of audio-visual equipment. 86th. Discuss the use of lighting control systems to improve energy efficiency and user comfort. 87th. Explain the different types of dimming systems and their compatibility with different light sources. 88th. Emphasize the importance of lighting designed to create a visually appealing and functional space. 89th. Discuss the use of daylight harvesting techniques to reduce energy consumption for lighting. 90th. Explain the different types of security systems and their integration with electrical systems. 91st. Emphasize the importance of access control and surveillance systems. 92nd. Discuss the use of biometrics for security authentication. 93rd. Explain the different types of building automation systems and their integration with electrical systems. 94th. Emphasize the importance of energy management in building automation systems. 95th. Discuss the use of wireless technologies for building automation. 96th. Explain the different types of elevator and escalator systems and their electrical requirements. 97th. Emphasize the importance of safety features in elevator and escalator systems. 98th. Discuss the use of renewable energy sources to power elevators and escalators. 99th. Explain the different types of electric vehicle charging stations and their installation requirements. 100th. Emphasize the importance of safety considerations for electric vehicle charging stations.